I think there might be something which is not quite compatible with the new versions of our network toolbox. Actually, there are counter-examples of using BP networks. Let us recall the data fitting problem we had in chapter 8, where we did two-dimensional interpolations. We have quite good fitting results. However, if you are trying to solve this kind of problem by using BP network, you may not always have good results. So instead, we will consider another kind of neural network. And this kind of neural network is called a RBF network. With the function, the transfer function, which is slightly different from the one we introduced, is the so-called RBF, or radial basis function like this. And in this function, we will still have three layers of feed-forward network. The first layer is the input layer. The other one is the layer with RDF functions. And the final layer should be the output with linear functions. So to use an RBF neural network, we can use the command simply by NEWRBE. We can create a neural network object, and then we can use theme. We do not have even to use stream process, since in the network creation process, we have already finished the stream process. So what we are trying to do is to use theme commands to validate the results. So now for our same problem, what we will have is use a command like this. Let's go back to this one. Net equals to new RDE. We should have sample point X and Y. So we can create a neural network and train this. And now we can use it to simulate the system Y naught equals to C net X0. And we can superimpose the results on top of the original results, on top of the this one was created wrongly by BP network we created earlier. However, this one is created by new RBF network, so the fitting results will be very good. And the fitting process is much simpler because we have to embed the training process in the network creation command. So let me summarize the neural network applications in data fitting. We have two methods in data fitting. One is by the use of interpolation. Actually, we have three methods. One is by interpolation. The other one is by polyfit or some similar command. We can approximate the original data by a mathematical function. And the third one is the neural network one. What are the differences between them? We have already interpolated, we have already compared these two earlier. This one, we do not care about the mathematical model. What we need to do is to find when x is equals to a certain value, what is the value of y? So this is the key point in interpolation. However, in polynomial fitting or in other fitting method, what we are interested in is to get a function like this. And in neural networks, also we need to get sorry, not the same thing. we need to get the model, not the function. The function could be very complicated. So we are not interested in the function. We need a model. So next time when you are trying to use, when you have already created a neural network model, so next time if you are trying to feed a signal into the neural network, you will use this model to calculate the value of y. So these are the differences. Mathematical model may not be created, or instead it will be create a neural network model. And you can use this model directly by the use of sim command. It does the same thing for interpolation. However, apart from the interpolation result, it will also have as the model. You can use the model later on. So this is a neural network. Sorry? So these are the differences. And in the slide, I will give a few examples, including two-dimensional fitting using RBF neural networks. So it could be different from the interpolation problems. It will have a model. So if you use this model, and neural network can be used in different ways. For instance, you can, in control, you will have neural network controllers of different kinds. So these are the neural networks. The next topic